so it'll be a nice little break before Thanksgiving. Synthetic division is a shortcut, essentially, for long division. It's a much more efficient way. It doesn't take nearly as long. It's not as tedious. However, it is only applicable when you are dividing by a linear. What does it mean to divide by a linear? It's not necessarily that there's not exponents, but what? The highest degree is 1, so it's in the form of y equals mx plus b, just your linear functions, okay? So yes, highest degree being 1, okay? So it has to be a linear equation or a linear function in order to use this new type of division that we're about to do. Okay, the same rules apply as long division as far as the fact that the polynomial has to be in standard form. Okay, so you need to go from highest degree to lowest degree, and then you want a placeholder in the event that you're missing any degrees. Okay, so you're checking, am I dividing by a linear? Am I in standard form? Do I need any placeholders? Those are the first 3 things you're asking yourself before you start synthetic division. Okay, once you've established that you're dividing by a linear, you have all of your terms and it's in standard form, then you can proceed. Okay, the first thing you want to do is figure out what would this root give me. So p plus 6, if I set that equal to 0, what would this root be? Negative 6, okay? So negative 6 is going to go on the outside, and instead of drawing a division house, or whatever you want to call it, you're going to draw it upside down. Okay, it needs to be thick enough that you can write 2 rows of numbers. Okay, you're going to have 2 rows of numbers. Okay, after you've drawn your little house, okay, you're taking the coefficient of every single term. Okay, so my 1p to the 4th, I'm just writing 1. 5p cubed, 5, minus 11p squared, minus 25p, plus 29. So I'm taking the signs of each of my coefficients and the number, and I'm writing it on the top row of my synthetic division little chart. Is everybody following so far? Okay. The first step is to bring down your first coefficient, which was 1. Okay? That's the first term you're bringing down. Okay? After you bring down the first term, you're multiplying your number outside times your number on the bottom. So 1 times negative 6 is going to be negative 6, and that is going underneath the 5. Okay, numbers in the house are going to be added together. Okay, so 5 plus a negative 6 is going to give you negative 1. Okay, and then you're done with that first column. Okay, now I have negative 6 times negative 1, which is going to give you positive 6. And you just move in this fashion. So you go down, diagonal, down, diagonal, down, diagonal. Okay, negative 11 plus 6, negative 5. Okay, then you have now negative 5 times negative 6, 30. Add negative 5, positive 5, good. And then 5 times negative 6, negative 30, add negative 1. Okay, the bottom right hand side will always be your remainder. Okay, the bottom right hand side is always your remainder. So when I write my quotient, okay, if I took a 4th degree and I divided by a linear, what's going to be the highest degree I have now? 3. Okay, you drop it by 1. So think if you had like x to the 4th and you divided it by x, that becomes what? X cubed. Okay, the same thing's happening here. Okay, we had a 4th degree polynomial, we divided by a linear, so now my highest term is x cubed, or in this case p cubed. So now each of these numbers here represents the coefficients of my quotient. Okay, so I have 1p cubed minus 1p squared minus 5p plus 5. That would be my quotient. And then if I add in my remainder, it would be plus a negative 1 over p plus 6. Okay, we'll see if anybody gets this. If this remainder was a 0, what does that tell you about p plus 6? It's a factor, okay? So if you get a remainder of 0, that tells you that you have a factor of your polynomial, okay? You'll see that again in the notes in a second, or a little while. But if this is a 0, that means you have a factor, okay? Questions on example 1? Obviously, we're going to do more for practice, but any questions on 1? Okay, kind of makes sense. Always go down, diagonal, making sure you're always adding in the house. And then always drop your degree by 1 when you're rewriting your quotient. Got it? Okay. Example 2. Okay, what is the number that's going to go outside? Negative 6 again. Okay, are we in standard form? Yes, do we need any placeholders? No, so I'm going 1, 11, 33, 24, 32. First step is to do what? Bring down that first number. Okay, then what? Which is, okay, add and that gives you 5. Then what? Multiply. Negative 30. Add to get positive 3. Multiply. Add to get. Multiply. Add to get. Very good. So it's a constant pattern. Multiply, add, multiply, add, multiply, add. Okay? Until you're done. And then the bottom right always represents the remainder. Okay, so if I were to rewrite now my quotient, what would it be? X cubed plus 5x squared plus 3x plus 6. That would be my quotient. And if I go ahead and tag on my remainder, I have plus a negative 4 over x plus 6. Easy? Yeah, that's fine. Questions on example 2? Alright, we'll just keep trucking along then. Number 3, what's going on the outside? Negative 8, am I in standard form? Yes, am I missing any terms? No, so we're going to proceed. 6, 53, 32, negative 61, and 19. Matthew, you're doing okay? Just following? Right. First thing, bring the 6 down. Alright, then what? Which is? Very good. Add and get 5. Then what? Add and get. Then what? Add and get. Sweet. Keep going. Very good. Add and get. what would your answer be? Quotient with the remainder. Mhm. Uh-huh. Uh-huh. Very good. Easy? Okay. So again, you can only do this if you're doing what? Dividing by a linear. Okay, I guarantee you somebody will do it when it's like x squared plus 1. Okay, make sure that it's linear. Okay, if for whatever reason you don't like this way, sweet, you can always do long division. Okay, long division always works, but there's more room for error, and it takes a lot longer. So on a test, you would definitely want to do the linear ones by synthetic division so that you would have more time on other questions. If you do everything by long division, chances are you'll run out of time. Okay, next one. What's going on the outside? -4. Okay, are we in standard form? Okay, are we missing any terms? Nope. So 6, 20, -15, and 9. First step, bring the 6 down. Then what? -24, you add and get. Very good. Then what? Add and get. Then what? Add and get. Very good. (6a² - 4a plus 1, and then your remainder would be
5/8 plus 4.
Awesome. Questions on example 4?
What?
Moving right along then. Example 5. What's going on the outside? -8. Alright, are we in standard form? Yes. Are we missing terms though?
Yes.
Okay, which one?
Cube.
P cubed. So I need to make sure that I have a 0 in the place of P cubed. Okay, so I'm going to have 1, 8, 0, 2, 19, 16. Okay, that 0 is incredibly important. If you don't have the 0, you'll get the whole thing wrong. Okay, you have to have every degree represented, okay, in order for synthetic to work. Okay, so make sure you double check that you have every term. Alright, then you proceed as normal. Okay, bringing down the 1. Okay, 1 times -8. -8 plus 8. 0 times -8. 0 plus 0. 8 times 0. 2 plus 0. 2 times -8. Plus 19. Times -8. Plus 16. So the same thing happens, except for you just have some zeros now. Okay, when you write this quotient, you don't have to write 0p cubed. Okay, so starting with this first term, what was your first degree? P to the 4th. Okay, you don't need to write the next 2 because we just don't write math like that. But then what do you go to? Okay, which is 2p, then what? And then if I added the remainder? Very good. What questions do we have on the front page before we spice it up just like a tad? Any questions on the front? Alright, so far, we're only using synthetic when you are dividing by a linear. The next step is to make sure you're what? In standard form. Then you're making sure what? You have all of your degrees. And then in the event that you're missing some, you're doing what? Putting a 0 or a placeholder. Okay, Your quotient represents all of your terms without the remainder, and then your remainder is that bottom right-hand box. If your remainder is 0, then your root that they divided by is a factor. Very good. Alright. Example 6 and example 7, okay, are a next kind of special case. What do you notice is different about 6 and 7? Okay, there's a coefficient in front of x, so you no longer just have like x plus 2, okay? We have a coefficient in front of it. So, for the first part, it's the same thing. When you have 3x minus 1 and you solve for that number on the outside, okay, you get 3x equals 1, and then x equals what? 1/3. Okay, so 1/3 is going on the outside. Are we in standard form? Yes. Do we have all of our terms? Yes. So we have 3, -7, 29, and -9. Okay, still doing just the same process. Nothing's changed yet. Okay. Bringing down my first term. 3 times 1/3? 1. -7 plus 1? -6 times 1/3? 29 plus -2? 27 times 1/3? 9 plus -9? So what does that tell you? Very good. 3x minus 1 is a factor. Okay, but we're not finished yet. Alright. So, when you have a linear function with a coefficient other than 1, okay, you notice that you kind of had to do an extra step. You weren't just adding or subtracting. You actually had to add or subtract and then divide. Okay? So, if you divide up here, you have to divide here. Okay? So, whatever you do at the beginning, you have to do at the end as well. So, what did I divide by up here? 3. A positive 3, right? Okay, so I need to divide now all of these coefficients by positive 3 as well. Okay, so the last step, not necessarily hard by any means, okay, but it's just remembering that you've got to divide by 3. So my coefficients really are 1, -2, and 9. So what would my quotient be?
X squared plus 2x plus 9.
Very good. Okay, but I guarantee you that people will forget, okay, and you obviously know that there's going to be an answer choice that's 3x squared minus 6x plus 27, because why wouldn't we give you that? Okay, you just have to make sure that you divide at the end. So if you divide at the beginning, you divide at the end. Questions on that?
If we did it the way we learned last class, it would just be boring.
It would just be in the event that you do have a remainder, so like say the remainder is 5, okay, you do not divide the remainder. You only divide your coefficient. So if you want to write that off to the side, you can. Okay, so that one was just a slightly tad bit different. Any questions on example 6? Alright. Example 7, what's going on the outside? -1/5. Okay, so we had 5x plus 1. We subtracted 1 from both sides, divided by 5, so x equaled -1/5. Okay, are we in standard form?
Yes.
Yes. Do we have any missing terms? No. Okay, so we have 5, -9, -12, -2. Bringing down my first term, 5 times -1/5. -9 plus -1. -10 times -1/5.
2.
2 plus -12
-10.
times -1/5.
2.
plus negative 2?
0.
Okay, so you know that 5x plus 1 is a factor. Okay, what do I have to do next? Divide it by 5. Why is it not negative 5? Because we had a negative 1/5, so why aren't we dividing by negative 5? Very good, because this is what's important. I divided by 5 here. Okay? Although it resulted in me getting a negative 1/5 because the other side was negative, what I actually divided by was just a positive 5. So that is what I have to do here. So, I get what as my quotient?
X squared minus 2x minus 2.
Very good. Questions on example 7? Okay, I'm sure you guys have already done them, but if you have not already, you're going to do 8 and 9. Okay, what are you looking for? If it's a factor, and you're going to determine that by looking for a remainder of 0. Okay, so do those real quick. It's going to take you probably about a minute or two if you haven't already done them. Raise your hand if you need more time. We're good. Alright, what'd you guys get on the first one? No or yes?
Yes.
Yes. And the second one? No. Are we in agreement? Do we need to see them worked out, or are we good? Okay, how do we feel on synthetic division? Thumbs up, down, sideways? Alright, mostly thumbs up then. Okay, you have a practice worksheet in front of you that you can work on. It's just a front side. The answers are on the board. We are doing a little exit ticket. It's not for a grade. Okay, we'll do it the last 30 minutes of class, because if you don't get 100, you're going to correct it until you do. Okay, and then that'll be it. Any questions?